Hey guys, so the thing I was going to cover today was going to be parametric equations. So for a little warm up, we were going to start with just eliminating a parameter via substitution. So the way you do this is notice we have an x equals something with a z in it, and y equals something with a z in it. So what you want to do is find z for one of these two. I normally pick the easier one and then just solve. So I'm going to pick this one because working with this seems a little tricky, but with this one, it's pretty straightforward, right? Just normal algebra. So if I want to solve for z, what I'm going to do is bring that 2 over. So I have y plus 2 equals 2z. Okay, and then just to solve for z, I just divide by 2. So we'll get z equals y plus 2 all over 2. Okay, so once we have this, then what we can do is just plug this in for z over here. So let's do that. So we'll come over here, get x equals 1 minus 4, make some space here, y plus z all over 2. Okay, so from here, if we do this, to divide fractions, we just flip the second and then multiply. So I'm going to take the reciprocal of this and just multiply it to 4. So that's going to look like this, times 4 over 1 times 2 over y plus z. Okay, so one more step is to multiply this out. We'll get y minus, remember when you multiply fractions, we multiply straight across. So we'll get 8 over y plus z. Okay, so this is kind of how you eliminate a parameter. Notice now we're only in terms of x and y. So that's kind of the big takeaway from stuff like this. Okay, so I'm going to clear all this out, and I'm going to go to what we were going to use today for session. Let's pull it up. Uh-oh, Harshey blows. I'm going to mute myself so you don't have to listen to this. Sorry about that. Okay, so where were we? So we come here, and it's just a simple analyze the problem. So notice we're given, it's analyze the problem, and the problem says eliminate the parameter to write the parametric equation as a rectangular equation. Okay, so let's go through the steps here. The first thing I did was I looked and wrote down what we had. So x equals 1 over t minus 2, and then y equals 4t plus 5. Okay, so like we did before, what you want to do is solve for one of the t's. Okay, so I decided to go for x equals 1 over t minus 2. I'm going to solve for t with this one. So the first thing is, if I'm trying to solve for t, I got to get it out of the denominator here. So what I did was I multiplied t minus 2 by both sides. So that got rid of it in the denominator here and moved it to the numerator over here. Okay, so now I have t minus 2 in parentheses times x equals 1. Now I just take that x and I divide it from both sides. So if I divide it here, it goes away, and then I just kind of move it to the bottom here. So now we have t minus 2 equals 1 over x. So last step, just add 2 over, and t equals 1 over x plus 2. Okay? So now comes the actual getting the rectangular equation. You take this t, and you're going to plug it into the other equation. So remember, I solved it with the x, so now I'm just going to plug it into the y over here. So I'm going to plug it in there. We're going to have y equals 4, parentheses 1 over x plus 2, in parentheses, plus 5. All right? So now I'm going to distribute this 4 out. So 4 times 1 over x is just 4 over x. 4 times 2 is 8. And the 5 is still there. So the last step is to just add these two together, and you get 13. So y equals 4 over x plus 13. And that would be our rectangular equation for that one. So this is one of the types, right? It's pretty easy algebra. So let's do one that probably involves a little bit more trig knowledge. Okay, so we have 8. Here we go. We have x equals 4 secant t and y equals 3 tangent t. Solve for secant t and tangent t. Oh, sorry. So those were our equations. So to get it, what you need to do, well, what you want to always try and do is solve for secant t and tangent t. Okay? So we know x is equal to 4 secant t, y is equal to 3 tangent t. So solve for secant t. It's pretty simple. Just divide that 4 out. You'll get x over 4 is equal to secant t. I basically do the same thing with the y portion. Just divide that 3 and you get y over 3 equals tangent t. Okay? So I noticed that tangent and secant have a relationship. It's one of our Pythagorean identities. Their relationship is 1 plus tangent squared t equals secant squared t. So that's a identity. Now remember, we said that tangent t is y over 3 and secant t is x over 4. So from this equation, I can sub those in where the square is. So plug it in, you get y over 3 squared, right? 1 plus y over 3 quantity squared is equal to x over 4 quantity squared. Okay, so then I just squared those fractions. And remember, when you square fractions, you square both the top and bottom. So 1 plus y squared over 9, and then is equal to x squared, and then 4 squared is 16. Okay, so next up, when you come here, you see we have, so this is us in rectangular form now, right? So the only thing left is to kind of get this looking like something we know. So I decided to take that y squared over 9 and subtract it from both sides. So I brought it over to the right. And now if you'll notice, we have a hyperbola, x squared over 16 minus y squared over 9, where a squared is equal to 16, and this hyperbola is opening up like this. All right, so it's opening right and left. Okay, so those were the two analyze it problems I was going to have y'all work on. So let's go to one of the problems we were going to work on. Oh wait, that's not it. Here it is. Okay, so since it's just me, I think I'm going to work on, let's do this one. So x equals 4 sine 2t, y equals 2 cosine 2t. Okay, so once again, trying to solve for sine of 2t. So that's going to be sine equals 4 over 4 is equal to sine of 2t. And then the y portion is going to be y is equal over 2 is equal to cosine 2t. Okay, so from here, I can use the Pythagorean identity of sine squared plus cosine squared is equal to 1. So going to, I guess, put that over here. So we'll have cosine squared plus sine squared. Oh, and it has to be 2t, because that's what we were dealing with before. 2t equal to 1. Okay, so remember cosine 2t is y over 2. So that's going to be y over 2 squared. And then plus, remember sine 2 of t was x over 4. So that's going to be x over 4 squared is equal to 1. Now, just square these out, and we'll have y squared over 4 plus x squared over 16 equal to 1. And if you notice, we have ourselves an ellipse where the a squared is the biggest number, which is the 16. So that's telling you that your ellipse, the major axis, is along the x-axis. Looks something like this. All right, well, that's all I had for y'all. Hope things are going well. Have a test review tomorrow. Hope to see you there.